Alright, so for this question, they asked you to find the work done by the force field F on the particle moving along a given path. So you would have to find the integral of F multiplied dr. Okay, so now let's find R of t. R of t is given by the equations right here, where C will be. So t I plus t cubed j. So t will be from 0 t to 6 because of the point right here they gave you. Alright, so now to find dr, you just take the derivative of r of t. Derivative of r of t is 1, so r of t respect to x right here is 1 for I component. Not respect to x, respect to t, but for the I components. So now 3t squared for the j. And now you have dr, and then you have f. So now you can compute in. So now the f right here we're given is xi plus 8yj. Now I'm just plugging the x and the y from the given equations right here. So your f will be x is t I plus 8t cubed j. Now you have both dr and f. You can compute the integral from 0 to 6, I'm sorry. It's from right here. That is your integration limit of integrations. And then you have f is t, the cross product. You just find the cross product of the f and the dr. So you will have t plus 3 times 8 is 24 t to the 5th dt. Now it's an easy integral. You can simply solve respect to t. So you get t squared over 2 plus 24 over 6 t to the 6th from 0 to 6. This will become 4. So now you'll have if you plug in 0 into the equations right here, you get 0. So the whole thing is out. So you only have 6 right here. 6 squared over 2 minus 4 is times 6 to the 6. So now the answer will be 8186642. This is your work.